Okay, this is going to be the last video on the trace protocol, and it's kind of like a low-level design, but it's not low-level at all, actually. I'm going to try to do it in 10 minutes, right? So, okay, so basically in one kind of concise sentence, unless I'm forgetting anything, it's basically pub sub with temporal state over time. If you know what pub sub is, but it's kind of self-explanatory. Yesterday, I don't want to go into all the basics because that's in the other two videos. So this is part 3. So definitely go watch those 2 videos if you haven't yet. And okay, so yeah, in one sense, it's pub sub with state over time saved for each node or entity. And then also again, trace stands for temporal reactive entity system. Okay, so this is what an entity is. And you can see how this could be put into some kind of UI. Like this could just be one page with your inputs. Remember the trace protocol or architecture has 3 parts. That's another reason why it's called trace. And one part is the inputs. They come from publisher entities, or if you're on this page, you could manually input it. And then the second part is the process definition. So a definition of what should happen when one cell reacts to another in the system. And then outputs. So I think this should actually say output because this is one instance of like this function running pretty much. You can see over here there's layers, and these layers represent the state over time. In other words, this is the current state, so whatever the inputs are for this, the process is defined for this, and whatever the output is, that gets saved as the state of that entity for that time. And then I have a little bit up here about how to put that in the implementation, which is, it could be as simple as just a date time. And you can get down to as granular level of periodicity as you want. Meaning you can get down to real granular time steps, or you can roll up to higher periods like days. Okay, so that's what temporal is. It's just state over time. And let me think. So that's an entity, pretty much, the 3 parts. That's the state over time. And then, and I mentioned how this is kind of like one page. Like you could envision how this could just be a really simple, even HTML page that just has 3 parts. It has a place for inputs or defining inputs. It has a place for defining the process, and it has a place for seeing the output. But you could also see this diagram as like a workflow diagram. And in this case, it's from top to bottom. But if you've used make.com or N8N, that's a workflow UI that goes from left to right. So obviously this is kind of a directed acyclic graph, but I think it's more, in my head, it's more directed graph that could be cyclic if you wanted it to. But that's just a little bit more description. So yeah, so if you had this as a workflow, then you could make a bunch of entities. And again, an entity can be as simple as, it needs a name, pretty much, a unique name. But then in the workflow app or UI, you can make these entities, and you're basically defining functions. By the way, you can define the process in like code, or you can define it as a prompt template, which I might also call prompt function at some point. But yeah, that's the process. And also the output can, in theory, be anything. It could be a file, a generated file, you know, or like some modification of the input file. This is not too much different from N8N or make.com at this point, or just a normal pub sub, but with some UI stuff against the normal pub sub. And then in terms of make and N8N, the temporal thing is what kind of sets this design apart from those two. And then also, okay, I'll get into composability after I talk about the publisher and subscriber parts. Also, I want to get into implementation options in terms of the requirements, which is just storage and compute. So that's what I'll get into for the rest of it. So yeah, so if you can come to this workflow app, define these entities, then you can have them subscribe to other entities, whether those are your other entities or someone else's entity. And what does that do in terms of, like, why is that useful? It helps a lot with traceability. And that's a really big thing, especially the temporal thing, because then you can measure where data is coming from and what the impact of those inputs are on any given entity. And that's important for the mission, pretty much. But okay, so that's publisher, subscriber. There's also a little bit of implementation detail. Say this function runs, this entity runs, it will basically save its output somewhere, and it will, I don't know what I want to call this yet, but one good word for it is it will certify the data. In other words, it will like publish that, hey, this data for this timestamp is ready in this location. So if you are a subscriber, you can access it now. That's pretty much what a certification is. Okay, so yeah, implementation requirements, and then I'll try to get back to composability. Actually, composability now. So the other idea that makes it a little bit different from Make or N8N is that you should be able to, or with this design, you're able to encapsulate entities within other entities. So if you come up with a good flow, you could say, make that its own node, which I think you can do that in N8N. But you can do that here too, whatever, with temporal state being a higher class citizen in the UI especially. Okay, so yeah, that is composability. So implementation requirements, all you need is storage and compute. Because you can obviously see how this could be implemented a million different ways in AWS, even with just a Lambda and an S3 bucket. But because all you're doing is you're just running a function, whatever that function is defined, and you're saving the output, and you're saying, hey, this output's done or ready. And you can do that in any number of ways. That's why I think this protocol is, or protocols like it, which is basically just a workflow, are so important so important to understand, because anyone can build something like this, because all you need is storage and compute. So there's a bunch of good options already, which obviously are mentioned, N8N and make.com. And if you don't know, those are workflow apps where you can easily create connections to other data sources like Google Drive or any cloud service, I think. You can create webhooks. You can define JavaScript and some Python functions, but you can make HTTP requests. You can do a lot of cloud stuff just in a UI, which is really cool. It's like no code backend pretty much. Okay, so But you can also do it, in Python with Google Cloud Function, which I've been doing a lot. And you don't have to use real storage. You can use something like Google Sheets to see. You can implement this whole thing in like N8N and Google Sheets, which is what I've been doing, and I'll show you guys more. But literally, I've been doing like all the implementation styles because, and here's one of the keys, is that what this simple kind of architecture / protocol does is it allows really easy implementation, so things can interface with each other and it doesn't matter how they're implemented, because almost anything can call, a webhook and say, hey, this data is ready, and pass one string. So you can implement it in many different ways, and it's easy to implement. You can, oh fuck, that was my timer. But the last thing I want to say is that the importance of this easy implementation, sorry, that battery died. The importance of that easy implementation is that you can choose the storage and compute based on a spectrum of low personal data control, or what I'll call centralization, to a degree of high personal data control, which I'll call decentralization. And so an example of more centralized stuff is like using N8N on their servers, and using like Google Sheets for storage, because that's owned by Google and it's obviously centralized, and using the LLMs for the prompt function executions that are in the cloud, like just vanilla ChatGPT that you call from like an API or whatever, and it runs in their cloud. And the opposite of that is like, for storage, you can use something like IPFS, which is Interplanetary File System, which I will probably talk about soon. Or for compute, you can use a smart contract. For compute, you can use a privacy-preserving smart contract. You can use a trusted execution environment. And with these kind of more decentralized, more personal data controls, end of the spectrum options, you can use, you can make really interesting workflows that I'm thinking things like some type of federated learning to train actual foundational models or whatever, or like what's public, what's not, are test results public or are they not, that kind of thing. Okay, so I gotta wrap it up. That's kind of the main, that's actually a really important technical detail of why it's so important for this to be easy to understand and easy to interface with anything based on all you need is storage and compute. Okay. That's it. Man, sorry that camera died.